Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to cover the topic solid fuels and proximate analysis of coal. The topic is solid fuels and proximate analysis of coal. In this session I am going to cover these topics. First one is solid fuel. What are the solid fuels? What are the solid fuels and percentage of carbon present in different types of solid fuels, percent of carbon present in the different types of solid fuels, and analysis of coal. What is the purpose of analysis of coal? And proximate analysis of coal. The proximate analysis of coal. We are going to learn these topics in this session. First one is solid fuel. The main solid fuels are wood, peat, lignite, coal, and charcoal. The solid fuels are wood, peat, lignite, coal, and charcoal. These are the solid fuels. These are comes under solid fuels. See, in that first one, coal. Coal is a fossil fuel which occurs in layers in the earth crust. Coal is example for fossil fuel. It occurs in the earth crust of the it occurs in earth crust. Coal is a fossil fuel. It occurs in earth crust. It is formed by the partial decay of the plant materials accumulated millions of years ago and further altered by action of heat and pressure. The coal is formed by the partial decay of plant materials. The partial decay of plant materials in the earth crust because of the heat and pressure. Because of the heat and pressure, the plant materials present in the earth crust undergo partial decay and forms a coal. The process of conversion of wood into a coal can be represented as the process of conversion of wood into a coal. It can be represented as follows. How the coal is prepared? The coal is prepared from partial decay of plant materials that are present in the earth crust because of high temperature and pressure present in the earth crust. Okay, the process of conversion of wood into a coal. This can be represented as follows. See, first the wood converted into peat. First the wood converted into peat. Then peat is converted into lignite, and the lignite converted into bituminous coal, and the bituminous coal converted into anthracite. First wood converted into peat, and then peat converted into lignite. The lignite converted into bituminous coal, and then anthracite is formed. Peat. What is peat? Peat is a brown in color and fibrous jelly-like mass. Peat is a brown color in shape and fibrous jelly-like mass. And lignite, these are soft. These are soft in nature. Lignite is soft in nature and it is in brown color and it is a lowest rank coal. The lignite is a lowest rank coal. Bituminous coals. These are pitch black to dark grey color. These are bituminous coals are pitch black to dark grey color. And anthracite. It is a class of highest rank coal. The highest rank coal is anthracite. The highest rank coal is anthracite and lignite is the lowest rank coal. See, the wood. First the wood converted into peat, the peat is converted into lignite, the lignite is converted into bituminous coal and bituminous coal gives the anthracite. Okay. In this, the lignite is a lowest rank coal that is in the soft and brown in color. Anthracite is a highest rank coal. The coal is formed in the earth crust because of the partial decay of the plant materials at high temperature and pressure. See, percentage of carbon present in the different solid fuels. Percentage of carbon present in different solid fuels. See, this is the fuel type. Here the percentage of carbon present in this fuel type of fuel, and this is the calorific value that gives when burnt, and these are the applications of the solid fuels. See, the solid fuel is first one is wood. It contains 50% of carbon. The wood contains 50% of carbon. On burning, the calorific value would produce the calorific value 4000 to 4500 kilocalorie per kg. Wood contains 50% of carbon percentage 50 and it produces the calorific value 4000 to 4500 kilocalorie per kg or kilogram. The applications of wood is in domestic fuel. We can use wood as a domestic fuel. The next solid fuel is peat. It contains the carbon percentage 50 to 60%. The peat contains the carbon percentage 50 to 60%. On burning, it produces 4125 to 5400 kilocalorie per kg. This is the calorific value of the peat. The applications of the peat, this is a solid fuel. Okay, the applications of the peat is, it is used in a deficiency of iron coal is prevailing. In case of iron coal is prevailing, then we use this peat solid fuel. The next solid fuel is lignite. The next solid fuel is lignite. It contains the percent of carbon is 60 to 70 percentage. The lignite, the carbon percentage present in the lignite solid fuel is 60 to 70 percentage. The calorific value it produces 6,500 to 7,100. 6,500 to 7,100 kilocalorie per kg. This is the calorific value. On burning, the lignite produces this much amount of calorific value. The applications of the lignite is for steam generation in thermal power plants. In thermal power plants, we use the lignite coal. In thermal power plants, we use the lignite coal for the steam generation. The next solid fuel is bituminous. It contains 80 to 90 percentage of carbon. 80 to 90 percentage of carbon. It produces the calorific value 8,000 to 8,500 kilocalorie per kg. It produces 8,000 to 8,500 kilocalorie per kg. The application of bituminous is in making coal gas and metallurgical coke. By using bituminous coal, we can make the coal gas and metallurgical coke. The last one is anthracite fuel. It contains high percentage of carbon, that is 90 to 98 percentage. 90 to 98 percentage of carbon. Highest rank of the coal is anthracite. It produces the calorific value 8,650 to 8,700 kilocalorie per kg. The applications of this anthracite solid fuel is in households and for steam rising. In households, we can use the anthracite, and also for steam rising. Okay, for steam rising, we can use the anthracite coal. These are the different types of solid fuels present in the these are the different types of solid fuels. In the solid fuels, each solid fuel contains different types of percentage of carbon, and it produces different types of calorific value. See, wood contains 50% of carbon. It produces 4,000 to 4,500 kilocalorie per kg calorific value. It can be used for domestic fuel. Similarly, the peat, this one also is solid fuel. It contains 50 to 60% of carbon, and it produces 4,125 to 5,400 kilocalorie per kg calorific value, and it can be used for in case of deficiency of iron coal, we can use this peat solid fuel. The next solid fuel is lignite. It contains 60 to 70% of carbon. It produces the calorific value 6,500 to 7,100 kilocalorie per kg, and it is used in the thermal power plant for the steam generation. The next solid fuel is bituminous. It contains 80 to 90% of carbon. It produces 8,000 to 8,500 kilocalorie per kg calorific value, and it is used for the preparation of metallurgical coke and coal gas. The last one is anthracite. It contains highest percentage of carbon, that is 90 to 98%. It produces the calorific value 8,650 to 8,700 kilocalorie per kg. It can be used for the steam rising and household purpose. Analysis of coal. See, why we have to analyze the coal. See, the analysis of coal is helpful in its ranking. By using analysis of coal, we can give the ranking. Which one is good one? Which one is the lowest one? Which solid fuel contain highest rank? Which one coal is which one's coal contain lowest rank? By using analysis, we can estimate which one is good. The classification and quality of coal. By using analysis, by analysis of coal, we can estimate the and classification also we can do the, and quality of the coal also we can check by using the analysis of coal. The elemental analysis. By elemental analysis, we can know how much amount of different types of element present in the coal we can estimate, or elemental analysis also we can done by the analysis of coal. And also industrial applications. Different types of coals can be used for the different types of industrial applications. Okay, for that purpose we have to analyze the coal. By using analysis of coal, we can do the analysis of coal is helpful in its ranking. By using analysis of coal, we can give the ranking to the coal, and the classification quality of the coal also we can check by using the analysis of coal. The elemental analysis also we can perform by using analysis of coal. and by analysis of coal is also helpful for the industrial applications. The assessment of the quality of coal is carried out by these two types of analysis. The assessment of the quality of the coal is carried by out of two types of analysis. The first one is proximate analysis. The second one is ultimate analysis. The first one is proximate analysis. The second one is ultimate analysis. See the proximate analysis. In this analysis, the percentage of carbon is indirectly determined. In the proximate analysis, the percentage of carbon is indirectly determined, not directly. We can determine indirectly by using this proximate analysis. It is a quantitative analysis of the following parameters. By using proximate analysis, we can quantitatively how much quantity present in this coal. We can measure these quantities like moisture content, volatile matter, and ash and fixed carbon. How much amount present in the coal we can estimate, we can determine by using this proximate analysis. The proximate analysis is a indirect determination of the percentage of carbon present in the coal, and also by using this proximate analysis we can estimate our quantitative amount we can calculate by using this proximate analysis. By using this proximate analysis we can estimate the moisture content and volatile matter and ash and fixed carbon present in the coal is we can quantitatively determine. See, in the proximate analysis there are 3 steps involved. In the first step, the known amount of coal is heated at 105 to 110 degrees centigrade for 1 hour, and the next step we have to heat 925 degrees centigrade for 7 minutes, and the third step we have to heat the 600 degrees centigrade in air without air conditions. Okay, these are the steps involved in the proximate analysis. See, first, estimation of moisture content in the coal. Okay, in proximate analysis, first we have to calculate the moisture content. See how we can calculate. About 1 gram of finely powdered air-dried coal sample is weighed in crucible. First, we have to take 1 gram of approximately 1 gram of coal, finely powdered coal we have to take in, and air-dried. Okay, then we have to perform air drying for that coal, and we have to weigh in a crucible. We have to take in a crucible and we have to weigh for approximately 1 gram of this finely powdered coal. The crucible is placed inside a electric hot air oven. The known weight coal content crucible, then we have to place inside the electric hot air oven. Inside the electric hot air oven that maintain at 105 to 110 degree centigrade for 1 hour. For 1 hour, we have to maintain 105 to 110 degree centigrade in hot air oven. The crucible is allowed to remain in oven for 1 hour. After that, we have to allow that crucible remain in for 1 hour. For 1 hour, we have to allow that remain. Okay. Then after, we have to take it out and cool in a desiccator and weigh. Then after, what we have to do? We have to cool that the heated crucible in a desiccator, and again we have to take weight of that crucible. The loss in weight is reported as a moisture. See, first step, what we have to do? Take approximately 1 gram of finely powdered charcoal in a crucible. Then we have to keep inside the hot air oven. We have to maintain the temperature 105 to 110 degrees centigrade for 1 hour. Then after, the crucible is allowed to remain for 1 hour in the oven, and then taken out the crucible from the oven, and we have to keep in a desiccator, and again we have to take weight of that crucible. Okay, the loss in weight, if the coal contain moisture at 105 degree to 110 degree centigrade, if you maintain, the moisture present in the coal will be evaporated. Means there is a loss in the crucible weight because of the moisture will be removed from the coal. Okay, if you compare from first weight W1 to W2, there is a weight loss because if you heating it 105 to 110 degrees centigrade for 1 hour, if the coal contain any moisture content, that will be removed from will be removed from the charcoal. Okay, the loss in weight is reported as a moisture. The loss in weight is reported as a moisture. See how we can calculate the percentage of moisture. There is a formula. The percentage of moisture equal to loss in weight. Loss in weight nothing but W2 minus W1. W1 is nothing but initial weight, W2 nothing but final weight after heating at 105 to 110 degree centigrade. The weight of the coal taken. What is the weight of the coal taken? That is W1. See, then formula becomes the percentage of moisture equal to W2 minus W1 by W1 into 100. The into 100 means we will get in the percentage. We will get the value in percent. That's why we have to multiply with 100. Okay. The percentage of moisture equal to loss in weight divided by weight of coal taken into 100. The loss of weight nothing but W2 minus W1. The weight of coal taken is W1 into 100. Then we will by this we can know the percentage of moisture present in the coal. We can know by this method. Then the next step is volatile matter. See how we can know the volatile matter present in the coal. The dried sample taken in a crucible and then covered with lid and placed in a electric furnace or muffle furnace maintained at 925 to plus or minus 20 degree centigrade. In this also, then the dried sample. Okay, now then you have to take the dried sample in this crucible and then covered with a lid. For that we have to insert a lid to that crucible and placed in a electric furnace or muffle furnace. Muffle furnace produce large amount of heat. Okay, it maintains the temperature at 925 to plus or minus 20 degree centigrade. The crucible is taken out of the oven after 7 minutes. We have to heat up to 7 minutes. At 925 degrees centigrade, we have to heat up to 7 minutes. Then after, we have to take out the crucible from the oven. The crucible is cooled first in air. First, we have to the crucible is allowed to cool in air and then keep in the desiccator. Then we have to keep in the desiccator and take the weight of that crucible. See, the loss in weight is reported as a volatile matter on percent basis. See, in previous step, W2 obtained, okay, from W1 to W2 obtained in first case, okay. In second case, what happens? See, if you heat at 925 degrees centigrade for 7 minutes, what happens? If the coal contain any volatile matters, that will be removed at 925 degrees centigrade 7 minutes. We are keeping the lid. So it occurs in unair conditions. Air is not present in this condition. So anaerobic conditions. We perform this in anaerobic conditions. We have to heat this dried charcoal at 925 degrees centigrade to 7 minutes. Then what happens? If the coal contain any volatile matter, that will be removed in next step. See the formula for the percentage of the volatile matter. The formula for the percentage of the volatile matter equal to loss in weight by weight of the coal taken into 100. See how we will get the loss in weight. See, we have heated the W2 grams of charcoal at 925 degrees centigrade for 7 minutes. The weight loss is W3. So the total weight loss is loss in weight equal to W3 minus W2. In next step, the second step, the weight loss is loss in weight equal to the W3 minus W2. Okay. Then weight of coal taken. How much we have taken coal in next step? W2. Okay. By W2 into 100. This is the percentage of volatile matter. This is the percentage of, here W1. The weight of the coal we have taken W1. W3 minus W2 divided by W1 into 100. That is the percentage of volatile matter. The third step is percentage of ash. How we can calculate the percentage of ash? The residual coal sample taken in a crucible and then heated without lid in muffle furnace at 700 plus or minus 50 degrees centigrade for half an hour. Okay. In previous step, what we have performed? We have heated the dry coal at 925 degrees centigrade plus or minus 20 degrees centigrade in anaerobic conditions. The lid is closed. Okay. Here we are performing the residual coal sample taken in a crucible. The residual coal we have to take in a crucible and then heated without lid. Here we have to heat without lid. Means we have to allow this coal to react with air or oxygen in muffle furnace at 700 to 50 degree centigrade with air condition. In air condition, we have to perform this heating. Okay, at 700 to plus or minus 50 degree centigrade for half an hour. Okay, the residual coal sample taken in crucible and then heated in air condition. We have to heat it air condition at 700 to plus or minus 50 degrees centigrade for half an hour. Okay, the crucible, it is then taken out. Then after you have to taken out the crucible and cooled first in air. First you have to cool in air and then you have to keep in desiccators and you have to take the weight of that crucible. Hearing, cooling and weighing are repeated till a constant weight is obtained. In every step you have to repeat the cooling and weighing are repeated till the constant weight is obtained. To get the constant weight, we have to repeat this experiment 2-3 times. Okay, several times. The residue is reported as ash percentage of the basis. The residue is reported as the ash and percent basis. See, the percentage of ash formula is weight of ash left. Finally, the final step we will get the only ash. In first step, any moisture content present, that will be removed. In the next step, any volatile content present in the coal, that will be removed. In third step, what happens? The combustion takes place. All the elements present in the coal will be reacts with oxygen. In presence of oxygen, we are burning heat. Okay, that's why any elements that are present in the coal, that will be react with oxygen, forms combustible products. The remaining, the non-combustible product is, that is ash, will be remain in the crucible. The last one, the last weight will contain only weight of the ash. See, the percentage of the percentage of ash equal to weight of ash left and weight of the coal taken into 100. See, weight of the ash left is W4. The weight of the ash left is W4 divided by weight of coal taken. How much we have taken coal? W1 into 100. This is the formula for the percentage of ash. What is the formula for percentage of moisture equal to W2 minus W1 by W1 into 100. The percentage of volatile matter equal to W3 minus W2 by W1 into 100. Then the percentage of ash equal to W4 by W1 into 100. This is the percentage of ash. Then the last final formula for fixed carbon equal to the percentage of fixed carbon, that is 100 minus. If you take the total percent, if you take 100, if you remove these moisture percentage, volatile matter percentage, ash percentage, then we will get the percentage of the fixed carbon present in the coal. Then the formula for the percentage of fixed carbon equal to 100 minus percentage of moisture and percentage of volatile matter plus percentage of ash. By this method, proximate analysis, we can calculate the fixed carbon. For in this proximate analysis, then first we have to calculate the percentage of moisture. Then next step you have to calculate the percentage of volatile matter. Then next step you have to calculate the percentage of ash present in the charcoal. Then after getting these three percentages, then you have to calculate the percentage of fixed carbon present in the charcoal by using proximate analysis, by using this formula 100 minus percentage of the moisture plus volatile matter plus ash. This is the formula for the fixed carbon percentage. This is the method for proximate analysis of the coal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.